Okay, let's take the derivative of r of t. So write down r prime of t equals, okay, this is a scalar function times a vector function, which means we can use one of the product rules. So you take the derivative of the first function, which is the scalar. That turns out to be negative 2 e to the 2t divided by the quantity e to the 2t plus 1 squared. And then, so you take the derivative of the first, and then you multiply that times the second, which is square root 2 e to the t, comma, e to the 2t, comma, negative 1. And then you take the first function, 1 over e to the 2t plus 1, that's the scalar, times the derivative of the second, which is just term by term derivatives of each component. Square root 2e to the t is the derivative of the square root of 2e to the t. 2e to the 2t is the derivative of e to the 2t. And 0 is the last one. Okay, well, that's it, but we want to simplify that a little bit. So I'm going to do that by factoring out a denominator, 1 divided by e to the 2t plus 1 squared. And I'm factoring that out from both this term and this term. Which leaves me if I distribute this, or it's not really distribution, it's really scalar multiplication times this vector. That leaves me with the vector negative 2 square root 2 e to the 3t, comma, negative 2 e to the 4t, comma, 2 e to the 2t. And over here I'm left with the factor e to the 2t plus 1 on top. So I'll show that scalar multiplication in a separate step. Let me make some room here. And also I need to close the bracket. Okay. So in the next step, I'm just going to recopy the first few items. Oops, no comma there. Okay, now I want to go ahead and scalar multiply this times each component. And okay, so that'll be plus. Now think about it. Once I multiply this times the first component, I actually have to distribute the square root of 2 e to the t to the e to the 2t plus the 1. So that gives me square root 2 e to the 3t plus square root 2 e to the t for the first component. For the second component, which I'll write down here, I'll get 2 e to the 4t plus 2 e to the 2t, and the third component will still be 0. Okay, let me make some room. And in the next step, I just want to add these vectors together. So if I take this guy and add it to this guy, I will have negative, well, hold on, let me recopy, e to the 2t plus 1, quantity squared on the outside. And then my vector will be, well, this guy plus this first guy here will be negative radical 2 e to the 3t. And we'll still have the square root of 2, so plus the square root of 2 e to the t. And so that's what you get when you add the first components of these vectors together. For the second component, so I want to add this guy, and I think we have some nice cancellation. So we're just left with 2e to the 2t. For the third guy, for the third component of the resulting vector, we get 0 plus 2e to the 2t. And so that's good enough for an answer.